Hello, everybody. Can everybody see the presentation here?
Yes.
Okay, wonderful. My name is Jorian. I'm an undergraduate student at the University of Texas at Tyler. I'm attending at the Houston Engineering Center, working with Dr. Biswas on the development of an educational fuel cell system for mechanical engineering coursework. I kind of want to go through this really quickly as to give others a chance to present as well. So briefly, here's some kind of contents that we're going to talk about, but largely I'll kind of explain this as a development, a student development over the last few years in terms of their coursework and in terms of the system itself. Some motivation behind kind of the development of the fuel cell system for educational purposes. Of course, we have project-based learning or laboratory setting learning that students are really excited about, and it helps drive home some essential core engineering principles. And largely, we talk about fuel cell systems because thermal and power systems are not commonly taught at the undergraduate level. There is some mention of thermal fluids and thermodynamics, but largely we want to talk about the systems in general. And then, of course, this is largely facilitated by student development and student projects. So we'll kind of go through this as we go. So this is kind of a timeline of sorts of the last couple of years. We started with students developing simulations in MATLAB from first principles, things like mass balance, energy balance of fuel cell systems. We go into design and analysis of an entire fuel cell system and not just the fuel cell itself. And then we go into kind of a hardware control data acquisition of the system. And then finally, we'll talk about applications and how it relates to specific coursework. Okay, some quick background on the fuel cell systems. We won't dive into this too much, but essentially it's an electromechanical device that converts hydrogen and oxygen into electricity, heat, and water. So it's an electromechanical device through a chemical reaction that produces power. If you add an electrolyzer, which is essentially a device that through electrolysis produces hydrogen, you can generate you can have a regenerative system. So your electrolyzer needs electricity to run, obviously. That generates hydrogen, which then powers the fuel cell. And so you can sort of create this power system that's regenerative in ways. So the first step is to look at a fuel cell itself in the system. And so the first step was students kind of developed a MATLAB simulation based on, again, mass balance, energy balance, and developed an S function or a system function within MATLAB to model that behavior. So in MATLAB Simulink, students were able to develop a model that shows voltage and current over time and the power generated by a singular fuel cell. So sort of the next steps was part of a capstone project. This kind of happened during the COVID pandemic. So students were largely limited by the physical things they could do. But what they did is they designed the system, an entire system that is, to include a hydrogen generator or electrolyzer. They incorporated some controls like a mass flow controller or valves and things like that. And they used a dummy load. And the idea is they should be able to develop the system such that they could build it and test it in the lab. Unfortunately, due to the COVID pandemic, they weren't able to actually physically implement, but their designs and their simulations lived on for sort of the next part, which was to develop a prototype design. So this was a part of another senior capstone course where they were able to actually build the entire system and start to perform some testing. And so here's some initial testing of that prototype system, wherein they're plotting the some temperatures of the fuel cell and the power generated using an electronic load. And then later, as I said, they actually finished the construction of the prototype with an entire system, sort of based on some common microcontrollers like the Arduino, and using common lab software packages like LabVIEW and MATLAB as well. So kind of throughout the development, there were some interesting challenges that students faced, and that is in order to interact with specific discrete devices like valves and like flow meters and things like that, there was some complexities. After all, these were largely mechanical engineering students working with some basic level electronics. And so there was some computer science knowledge that's kind of necessary to make that happen. So they were kind of facing some difficulties there. Another thing was we wanted to make this thing easy to use for lower level courses. So something that students could interact with and kind of understand how the power was being generated. So that was another challenge. And then we also wanted to take this power system and apply it to a real world example. So from those two challenges, we sort of branched in two paths. So we want to sort of focus on the hardware control and data acquisition of the fuel cell system, and we want to focus on implementation. So that leads us kind of into some work that we're currently developing. So the first part of this hardware control and acquisition system, this is essentially a DAC device, an in-house built DAC device by students. So this is the student development of a sort of universal data acquisition device. So this kind of includes, but is not limited to, applying a fuel cell system and collecting and controlling that system, removing that system, and perhaps thinking about another thermal fluid system, say like a heat exchanger, and allowing that to interface with the system as well. So that data acquisition device is currently being developed. So this is the kind of the first part, is creating that user experience through a unified hardware data collection device. So that's sort of the first way of addressing these things. The next thing is providing an actual applications for students to work on in courses. So this is one of the course projects for an energy conversion course, where the students are working on a project to design an e-bike charging station, wherein they are incorporating things like a solar or PV panel to power the electrolyzer, which generates hydrogen fuel, which powers the fuel cell, which then can charge a real load, this time being an electric bicycle. So overall, from first principle simulation to the design, proposed design, to simulations of a full system, fuel cell system, to the actual prototype of the fuel cell system, that led to two branches, one being a control system to manage many types of experimental apparatus, to the actual implementation plan of an entire energy system, something that students can touch and feel, sit on an e-bike and get to ride it around campus, that's been charged by an actual fuel cell system that students help develop. So that's sort of the development of a fuel cell system for undergraduate engineering coursework. And I guess I'll open it to questions very briefly, and we'll go on to the next presentation.